All right, IM2 classes. Today we're talking about properties of exponents. Some of this might be a little bit of review for you, but let's get right into it. First two properties we're going to talk about are the zero exponent and a negative exponent. The zero exponent's the easiest one to remember. Anything to the zero power is one. I'll explain that better in class, why anything to the zero power is one and not zero. It's a common misconception that anything in zero power would be zero, but it's one. Anything to the zero power is one. Negative exponents are the reciprocal. So here's a good example here. If you have 4 to the negative 2, doesn't make it negative 16. It takes the reciprocal, so it makes it a fraction with the 4 on the bottom, and then the exponent becomes positive. Here's another example, just in simple terms. So make a fraction, then becomes positive. Let me do another example here. If we had a negative exponent on the bottom of a fraction, the fraction would flip. The a would go on top, the exponent would become on bottom. And so it's vice versa. Again, it might be easy to think of that as here, it flips the fraction and then the exponent becomes positive. So let's do a couple examples. Evaluate the expression. Anything to zero power is one. That one's easy. All right. This one here, negative 2 to the negative 4 power. So again, it might be easier to think of this as a fraction there. The negative exponent flips the fraction, so it's going to be 1 over negative 2, and then the exponent becomes positive. If we want to evaluate that, negative 2 times negative 2 is positive 4, times negative 2 again is positive 8, or negative 8 times negative 2 again, it'd be positive 16. So this would be 1 over 16. Negative 16, 1 over 16. Here's an example. We're going to combine both of them. So negative 5 to the 0 power. First thing I'm going to do is take care of that 0 power. That negative 5 is going to become 1. And then I have 2 to the negative 2. And then the fraction flips. So the 2 goes to the top, and the exponent becomes positive, 1 on bottom. So it just flips the fraction. And then we could evaluate that even further, because we know 2 squared is 4. 4 over 1 is just 4. Easy. Here's another one. We're going to simplify the expression, write your answer using only positive exponents. So I'm going to rewrite it down here, just so I have a little bit more space to work out. First thing I'm going to do is take care of that 0 exponent. Anything 0 power is 1. So 3 to the negative 2, x to the negative 5. All right. So here, think of it. These both switch sides of the fraction. The 3 to the negative 2 goes to the bottom, and the exponent becomes positive. Same thing is going to happen to the x to the negative 5. It moves to the bottom of the fraction. The exponent becomes positive. 1 goes on top. We can evaluate that a little bit more because we know what 3 squared is. That's 9, x to the 5th. For these, when we're doing them in class, if you have a numbered base, if it's the squared or the 3rd power, you can evaluate it. But bigger than that, I don't expect you to evaluate it. If it's going to be something you need a calculator to work out, you can just leave it in this one. This would be okay. But we know what 3 squared is, so that's why I'm going all the way there. All right, another long example. Nice, I like it. So first thing I'm going to do is I'm going to evaluate some positive exponents. So this 2 squared is 4. I know what that is, so I'm just going to clean that up a little bit. Y to the negative. Y to the, okay. Here, 8 to the negative 1. Z to the 1st, or Z to the 0 power would just be 1. I'm just putting in there so we can see that we evaluate it. We don't actually need to put a 1 in there. We could just kind of drop it, but just so we can see that that z to the 0 power turned into 1, and then x to the -7. All right, so you can draw this. Anything that has a negative exponent is going to switch sides of the fraction and become positive. So I'm going to look here. It's kind of put a multiplication symbol in there so we can see the -6 is only on the y, not the 4. So the 4 is positive. That's going to stay up here on top. All right. Y to the -6. That's going to move the y to the bottom, and then the exponent becomes positive. Moving down here, 8 to the -1st. That's going to move that up to the top, and the exponent becomes positive. We can kind of just ignore the 1 now. We don't need to move it around. X to the -7, that's going to move to the top, and the exponent becomes positive. And then I'm going to simplify this even more. 8 to the 1st is 8, so 4 times 8 is 32. X to the 7th, y to the 6th. And there we go. Assignment right there in the book. Moving on, we are going to do the next properties of exponents, the product property, the quotient property, and the power property. So product property, when you're multiplying with exponents and you have the same base, you add the exponents together. So 4 to the 6 times 4 to the 3rd is 4 to the 6 plus 3 is 9. I can show you this one real quick. X squared times x cubed. All right. If we were to expand that, x squared is x times x. X cubed is x times x times x. And then we have 1, 2, 3, 4, 5. X is multiplied total. So that's x to the 5th, or 2 plus 3. So that's why the division works there. Quotient, you subtract. If you have a you subtract the top exponent or the bottom exponent from the top. So 4 to the 6th divided by 4 to the 3rd. 6 minus 3 is -4. So again, similar to that one, if we add x to the 4th over x squared, that'd be x times x times x times x. X squared would be x times x. Common factors in top and bottom cancel out. So you're left with just 2 x's on top. Would be x squared over 1, or just x squared. Not going to fix that part. Power property. So if you're taking a power of a power, or you multiply the exponents. So 4 to the 6th to 3rd power is 6 times 3 is 4. So why don't we show this one real quick? Let's say we had x squared cubed. We'll do the cube. So that's going to be x squared. No, we're going to do x squared times x squared times x squared. So squared times, so that'd be x squared is x times x. So then x times x times x times x. So we have x to the 6th total, or 2 times 3. Let's do some examples. 3 squared times 3 to the 6th, that is a power property. We just need to add those. So 2 plus 6 is 8. So this is 3 to the 8th. I'm not going to put that into a calculator to figure that out. This one, it's 2 minus 7, which would be -5. So there's 2 ways to think about this. If we do 2 minus 7, that's -4 to the -5. We want positive exponents only. We know that if we make that fraction, it flips the fraction, that negative. So it's -4 to the +5. The other way to think about that is, sometimes I like to think about it expanding. So if I had -4 squared down here, so that's going to be times -4 over -4 to the 7th. Ooh. 1, 2, 3, 4, 5, 6, 7. 2 on the bottom will cancel out 2 on top. So because we have more -4s on the bottom, the exponent ends up on the bottom. That's how I like to think about that one. All right. Next one here, z to the 4th to the -3. 4 times -3 is -12. And again, that flips the fraction, so it'd be 1 over z to the +12 is what we were looking for. So combining a couple of the ones, I'm going to take this couple steps. So I'm going to simplify the top first, add those exponents. So z to the a times z squared, that's z to the 10. And then the z to the 5th is still there. And then 10 z's on top, 5 z's on bottom, cancel out 5 z's on top. So you're just going to be left with 5 z's on top. If it makes you feel better, you can put over 1, or just z to the 5th is fine. Next set of problems right there. And then our last bit here. So the power on power. So if you have a product and you're taking the power of a product, this exponent goes to each base in the parentheses. So 3 times 2 to the 5th is the same thing as 3 to the 5th times 2 to the 5th. Same thing if it's a quotient. 3 over 2 to the 5th is the same thing as 3 to the 5th to the 5th. The exponent gets distributed to each base in the parentheses. So let's do an example here. All right, -1.5. So this is times y. Sometimes it helps if you put a dot in there. So each base in there gets the exponent. So I'm going to put the -1.5 in parentheses because it's negative. It's -1.5 squared times y squared. I can do this one. -1.5 squared is positive 2.25. So 2.25 y squared would be the fully simplified. I'd be okay if you left it like that. This one here, again, this power gets applied to each base in there. So it's going to be a to the 3rd on top, and then -10 to the 3rd on bottom. You can leave it there. -10 to the 3rd is going to be -1000. That'd be the fully simplified. But if you left it like that, I'd be fine with that. Again, this one here, that's 3 times d squared. So when each of these gets a 4th exponent, so 3 to the 4th times d to the 4th over 2 to the 4th. This absolutely fine to leave it like that. I know 3 to the 4th is 81. So I'll do that. 2 to the 4th is 16. So I'll work those out in my head because I know what those are. If you need to do a calculator, don't worry about it. Just use this. That's fine here. This one here again. Actually, I'm going to make this a little bit easier. I'm going to take care of the negative exponent first. So what I'm going to do, that out of the way. What I'm going to do is actually flip the fraction first. So it's going to go 3 on top, 2x on bottom, and then the 5 becomes positive. So it flips the fraction, exponent becomes positive, and now that's 2 times. Make sure. I'm going to write this a little bit neater. Why not? So 2x, I'm going to write as 2 times x on bottom, and then 3 on top, and it's to the 5th power. So 3 to the 5th on top, and then it's 2 to the 5th times x to the 5th. Again, those are larger powers, so you could leave it like that. I know 3 to the 5th is 243. 2 to the 5th is 32. So, but again, if you don't want to work those out, you can leave it as 3 to the 5th over 2 to the 5th, x to the 5th. That is fine. I'm multiplying it out. What the heck? Okay. There's a 5 there. There we go. All right. So here's one combining everything. So I'm going to take this in steps. I'm going to remember these are all getting multiplied. So it's multiplied. These are all multiplied. Another thing we need to remember. No, that's actually fine. So I'm going to give every base in there the exponent of 4, it gets multiplied. So 2 to the 4th. So 2 to the 4th. X to the negative 2 to the 4th. I'm going to multiply those. So it's x, negative 2 times 4 is negative 8. Y to the 3rd to the 4th. 3 times 4 is 12. So that's y to the 12th. Here, 3 to the 4th. All right. X, that's just going to be x to the 4th. Y to the negative 4 to the 4th. So that's going to be y to the negative 16. All right. I'm going to clean this up a little bit. Actually, no. So again, draw a line. Now I'm going to take care of negative exponents. I'm going to look at each base here. If it has a positive exponent, it stays on the side of the fraction that's already on. If it has a negative exponent, it goes to the other side, becomes positive. So here, the 2 has a positive exponent, so that stays on top. The x has a negative exponent. That's going to move to the bottom and become positive. Switches sides because of the negative exponent. The y has a positive exponent, so that stays on top, becomes positive. The 3 has a positive exponent that stays where it's at, becomes positive, or stays there, nothing changes. X to the 4th, positive exponent, that stays on the bottom. Y to the negative 16th, negative exponent moves to the top and becomes positive. So again, just these negative exponents, all that's happening is these with the negative exponents are switching sides and becoming positive. Everything else is staying where it's at. Now I'm going to simplify stuff a little bit more. I'll go ahead and evaluate this. 2 to the 4th is 16. Again, you can leave it like 2 to the 4th if you want. Y to the 12th times y to the 16th. That is y. You add those. 12 plus 16 is 28. 28. 3 to the 4th, that is 81. X to the 8th times x to the 4th is x to the 12th. And there we go. So it looks like a lot, but if you just step by step look at each piece individually, it is not too bad. There we go. 16 y to the 28th over 81 x to the 12th. I think that's going to do it for us. Yeah, so there's the last assignment from the book. And that is it. We will see you guys next time.